Hi students, this is a short movie to discuss the Chapter 9 study guide problems. It seemed like there was some issues understanding these particular problems. So I want to go over them now just so you can see how they're done. Okay, so in problem number 54, we're going to apply a composite tolerance to permit a 155 plus or minus 1 thousandths diameter shaft to pass through both of those holes. So the shaft must be located within the 25 thousandths diameter at MMC relative to datum A primary, datum B secondary, and datum C tertiary. So we start this by drawing our composite feature control frame here, where we have one tolerance symbol, that is one tolerance symbol, and two segments of this composite tolerance. Now the first one, like the problem stated, the upper one says the shaft must be located within a 25 thousandths diameter zone at MMC relative to datums A, B, and C. Okay, so this first line is true position, diametrical, 25 thousandths at MMC to A, B, and C. Okay, so that establishes the tolerance zone. Now we need to have a tolerance for the location of these two holes relative to each other, because what they're going to do, think of a hinge pin. Okay, I'm going to put a pin through both of these holes. Now it has to fit. Okay, so how do I size this up? Okay, so we know that if we're talking about our hole size here, it's given as 170 thousandths plus or minus 2. That's 170 thousandths minus 2 thousandths for the tolerance gives us a MMC condition of that first hole at 168 thousandths. That's the MMC of the hole. Now the shaft that has to fit through there is 155 thousandths plus or minus 1. So the MMC of the shaft is 155 thousandths plus 1, which is 156 thousandths. Okay, so the idea here is we have the MMC of the hole is at 168 thousandths, and the MMC of the shaft is at 156 thousandths. If I subtract 156 from 168, I get 12 thousandths. Now, this shaft at the maximum material condition of 156,000 will fit through both of those holes if I allow a 12 thousandths and no more true positional tolerance at MMC. Okay, so the second segment would be this 12 thousandths at MMC. Okay, I hope that helps you understand this problem. The next one people had some trouble with was designing a functional gauge for this simple sketch here. So what we have is a counterbore hole, essentially, in a square block. Okay, the main hole here, datum A, has a tolerance of 578 plus 3 minus 1. Wait, that is the upper hole. Okay, datum A here has a tolerance of 386 plus 2 minus 1 thousandth. Okay, now the hole with the true position tolerance here is the concentric hole on top, and it's 578 plus 3 minus 1. Okay, so I'm going to make a plug gauge to check that positional tolerance. Okay, so when I place this plug gauge in and I can fit it into this feature here, I will know that this feature here meets that positional tolerance. Okay, so how do I design this plug gauge? Well, first of all, I have the two dimensions, the 300 and the 750 thousandths length. And then here is our diameters of the plug. So on the right end, this is the plug that's going to pick up datum A. So the size of this plug is 386 minus 1, which is the MMC condition of the datum A hole. Now, the plug on the other side is going to be to the virtual condition of the hole. And how do we get to the virtual condition? We take the 578, which is the size, minus 1 thousandth, which is the tolerance, minus 9 thousandths, which is the positional tolerance. Okay, so 578 minus 1,000th, which is a size tolerance, minus another 9,000ths, which is a positional tolerance, and that gives us the virtual condition of 568 thousandths. So if this plug would be able to be inserted into this hole, then I can say these two features meet that positional tolerance. Okay, so the last one I want to talk about here is the number 50, about designing a functional gauge. Okay, so what I have here is here's our part, okay, and it has these 4 holes in it, and the 4 holes are first of all designed by, it's defined by these. If this was an actual GD&T, of course these would be basic dimensions, but they're not shown as basic. But they'd have to be basic for this tolerance here to be applicable. Okay, so what my functional gauge looks like, I have datums A and datums B, which is up here, and then datum C. So my functional gauge has features that simulate those 3 datums. Okay, what I mean is there's this plate here, and this bottom lower surface of my functional gauge plate picks up datum A. It simulates datum A. Now this piece of the fixture simulates datum B. Okay, and this could be just a rectangular bar stock that sits up and it's fastened to this piece here. That forms the gauge. And now this bar here is going to pick up my datum C. Okay, and then this is going to have 4 pins. This functional gauge is going to have 4 pins, and those 4 pins are going to check this feature control frame. Okay, so we've got 4 times 0.302 plus 5 minus nothing. So therefore, this 302 is the MMC of that hole. Then we have a 26 thousandths positional tolerance at MMC. Since we have an MMC in this tolerance here, we can use a functional gauge to check these features. So that's what we're doing here. Now, to get the size of the pins right, what we do is we take our 302 minus 0, which is our size tolerance. That gives us our whole MMC of 302, and I subtract from that the 26 thousandths positional tolerance, and that 276 thousandths becomes my virtual condition for those holes. So what I do is I create this gauge. This gauge simulates this functional gauge simulates datum A here. The part will sit on it, and the functional gauge also simulates datum B with this piece here, and it simulates datum C with this piece here. And it has 4 pins, and these 4 pins are designed to go clear through the part at the virtual condition of the part. Okay, joking a little bit. I'm going to have to end the movie here. Thank you.